Okay, hello. So today we're going to talk about quadratic equations. So quadratic equations are equations of the form y equals ax squared plus bx plus c. So they're quadratic. The quadratic part really refers to this x squared term. So you have the highest power of x is x squared, and then you can also have powers of x and constant terms as well. But you don't have any higher powers of x, so no x cubes, x to the fourth, anything like that. Also, no 1 over x's or sines or cosines or natural logs. You just have x squared, x, and a constant term added together. Okay? And so quadratic functions, just to kind of remind you what they look like and some properties of them, is let's say they kind of look like kind of a combination between a u and a v. I could have drawn that maybe a little bit better. There are certain properties of this. The first one is that they're symmetric about a central line. Now, mine could have been more symmetric, but hopefully you get the idea. So it's symmetric about that central line, that central vertical line that goes through this point right here, which is called the vertex. So the vertex is that turnaround point. So this is a concave up. So the lowest point would be the vertex. If it was concave down, kind of shaped the other way, then the highest point would be the vertex. But it's that point where it turns around. Also, something we're going to talk about today are these intersection points. So these points are the x-intercepts. So where they cross the x-axis are called the x-intercepts. And this point right here, this is the y-intercepts. Okay, so those are some major parts of this quadratic function that we're going to talk about. So in terms of applications, the one that's most commonly referred to is that of a thrown object if you ignore air resistance. So if you throw a ball through the air, it follows kind of a parabolic path, which is basically just a concave down quadratic function. Okay. But there are other things also that are described by quadratic functions. Okay, so let's review what we know about quadratic functions. So first, we have our toolbox function. Y equals x squared. So if you remember y equals x squared, so let me draw a graph here. So we have, let me maybe draw this with a, so we have points here. Okay, so the central point, the vertex point, is 0, 0. Point 1, 1, 2, 4, and then additionally you could draw these other ones, 3, 9. But basically the idea is the x value gets squared to give you your y value. So 1 squared is 1, 2 squared is 4, I forgot that. 3 squared is 9. And then over here also, negative 1, 1. And actually it's the same pattern. Negative 1 squared is positive 1. Negative 2 squared is positive 4. Negative 3 squared is positive 9. So that's our toolkit function. And those are the points that, that we have. So one way of constructing this, which is something we're going to talk about today, is graphing these points relative to this vertex. All right. Points relative to the vertex. So there's a certain pattern that occurs here, which is you start at 0, 0, you go over 1 and up 1, right, to get that next point, and then you go over 2 and up 4. Okay, and then you go over 3 and up 9. Okay, and you can go the other direction as well. Left 1 up 1, left 2 up 4, left 3 up 9, and you can kind of construct it. So once you have the location of the vertex, just understanding these relative points 1, 1, 2, 4, 3, 9, you can graph the other functions. And so there are a lot of ways of thinking about these, but it turns out, in my opinion, what we're going to do today, it's really important that you're able to graph these points relative to this vertex. That's going to come in real handy a little bit later on. Okay, so an example of that is different sort of graphical transformations. So if you remember the graphical transformations, we're going to do different graphical transformations on this. Okay, I'm sorry my handwriting is not that great. But we're going to do a couple. We're going to do horizontal and vertical shifts. Okay, so that is going to be the form x minus h squared plus k. We're also going to do vertical reflections. So minus x squared would be a vertical reflection. We're going to do vertical stretching, which would be something like a x squared, where a is greater than 1. So the example I'm going to show you, but it could be really a is any number greater than 1, would be 2x squared, would be a vertical stretch. We're also going to do vertical compression, which again is the form ax squared, but a is between 0 and 1. So an example of this would be like 1/2 x squared. So starting with your toolbox function, you can do these different transformations, and we'll go through them. But one of the ways I think it's helpful to think about is thinking about starting at the vertex and then graphing the other points using this kind of 1, 1, 2, 4, 3, 9 kind of pattern. And I'll go through that. So let's start off by talking about horizontal and vertical shifts. All right, so horizontal and vertical shifts. Okay. So remember, the idea behind these shifts is that you are given some function, and all you do is you take it. It doesn't change its shape, but you just move it left or right and up and down. So let's say that we have some function y is equal to x minus 2 squared plus 3. Okay. So the way we would interpret this, if you remember that when you subtract a number from x and it's inside the function, this means it's 2 to the right. And if you add a number outside of the function, that's going to be a vertical shift. And in this case, it'd be 3 upward. So right and up are considered the positive directions, but when you're dealing with x, subtracting it makes it go in the positive direction, whereas you add y, adding 3 makes it go up in the positive direction. So x and y have behavior that's sort of flipped. All right, so how would you graph something like this? So let's draw this like this. So what I'm going to do is I'm going to graph the original function, and let's do red. Well, let's do green. So the original function has 0, 0, 1, 1, 2, 4, 3, 3, 9, and then it's symmetric, right? So you can kind of go over here and figure out the symmetric points. So this is y equals x squared. That's our toolbox function. Now, basically what we are going to do is we're going to shift it. So here I'll use blue for our new function. We're going to shift it 2 to the right and 3 up. So I want to start at my vertex, and I'm going to shift this vertex 2 to the right and 3 up. So that's my new vertex right there. 2 to the right and 3 up. And that's basically what I'm going to do for all the points. Now, I could start at this point and go 2 to the right and 3 up and 2 to the right and 3 up. But the way I want you to kind of think about this is that we're following this pattern of going, 1, 1. Start at the vertex, go 1, 1 to get your next point, and then go 2, 4. Using that vertex as kind of a relative point to graph the other points. So we have 1 over 1, 1 over 2, 1, 2, 3, 4. And then here, I'll just draw those. I could maybe draw the 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Some point over here. And it should be symmetric about this point right here. So our new shifted function is going to look like this. So this is our function y equals x minus 2 squared plus 3. So do you see, basically, the only point I really shifted was the vertex. And then I use this relative points to kind of figure out what the rest of this. So this graph is this blue line right there. Okay. So here's another example. So let's say that we have, y equals x plus 1 squared minus 4. So again, this pattern, I'm sorry, this looks kind of messed up, but it's x. Here, I'll just rewrite it. Is if you see a plus in the x, that means you're moving to the left, so 1 left. And if you see a minus in this number outside, that's going to be downward, so it's going to be 4 down. So we have 1 left and 4 down, and it's the same idea here, is that we are going to try to graph this by figuring out where the vertex is located. So my vertex normally is 0, 0, but now I'm going to shift it 1 left and 4 down. 1, 2, 3, 4. So this is my new vertex right here. And then all I'm going to do is I'm just going to follow this pattern. Here, I'll use blue. So there's my vertex. And I'm going to follow this pattern. 1 to the right, 1 up. 2 to the right, 4 up. And then 3 to the right, 9 up. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I probably could do 4, 16, but I'm going to kind of stop there. This is my line of symmetry here, right, through this vertex here. So I'm going to kind of make symmetric points over here. So that is my function y equals x plus 1 squared minus 4. All right. So I really like this idea of doing this. This is the way I would approach it, is just shift the vertex and then know how to graph all the other points with respect to that vertex. And we'll see when we do like the vertical stretching and compression. It's a little bit more complicated, but not that much more complicated. But that's what we're going to do next, okay? So horizontal and vertical shifts. There are other ways of doing this. Obviously, we talked about this a lot. There are like a million ways of doing everything. But this is the way that I think is probably the most straightforward. Okay, I'm going to switch markers. I think this one's a little bit better. All right, so the next thing I'm going to show you is the vertical reflection. And basically, the equation that we're going to graph is y equals negative x squared. Okay? So basically, the vertical reflection, what it does is it takes y values and it switches them to negative y. So positive y's become negative y's turn into positive y's, right? Because you just flip the sign of whatever the y value is, the x values remain the same. So if you're graphing something like this, here again, we'll start off with our toolkit function. So I believe I did my toolkit function was this one. So 1, 1, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're symmetric about this point. So we have that point, we have that point, and we have that point. So that's my y equals x squared. Okay. So the vertical reflection just takes all these points, and when you do a vertical reflection, instead of going, 1 and up 1, we're going to do the opposite, which is we're going to go 1 to the right and go down. All right, so we're going down instead of up. So normally you would go 2 and then up 4, but we're going to go 2 and we're going to go down 4. Okay, so that's the idea for graphing these. So again, you start at the vertex and you go 1, down 1, 2, down 4, 3, down 9, 5, 6, 7, 8, 9. And then it should be symmetric still about this point. So you should have a graph that looks like this. So that would be the vertical reflection. And remember, it's called vertical reflection. You're basically flipping it over the x-axis, right? So it just kind of flips over. Okay, vertical reflection. Next, let's talk about vertical stretching and compression. So we'll start off with vertical stretching. Actually, we're going to use this half for vertical stretching. We'll use this half for vertical compression, which we'll do in a second. But let's say that we have y equals 2x squared. So basically, the idea behind this is that it takes y values, the y coordinates, and it just doubles all the y coordinates. All right, so it stretches it vertically. So if we have our graph, so let's graph it. Let's start off with our toolkit function again here. So this is x, this is y. So our toolkit function starts at 0, 0, 1, 1, 2, 4, 3, 9. So that's y equals x squared. So our vertical thing is normally we would go here actually. So normally when we have our regular tool, we go 1 to the right, 1 up, 2 to the right, 4 up. But now that we're doing a vertical stretching, what's going to happen is these movements upward are going to double. So we go 1 to the right and 2 up, and we're going to go 2 to the right. Try to make this long enough, and 8 up. All right, so we're just doubling how much we're going up in the y direction, but it's the same idea. So in this case, we have the same vertex point, which is 0, 0. But what we're going to do is we're going to go 1 and then 2, and we'll go 2 and then 8. 4, 5, 6, 7, 8. Yeah, I think we did that right. And so then you get these points over here. And I could do 3 and 18 as well, but I don't want to spend the time to count that. But it's going to look something like this. So this would be our y equals 2x squared. So you can see all those points on there have been kind of like stretched out, kind of like taffy. So this point over here, which is at 1, got stretched to 2. This point, which was at y equals 4, got stretched to y equals 8. This point would have been stretched over here as well. So you get generally a skinnier and taller function when you do vertical stretching. Okay. Now there could also be vertical compression, which is y equals, let's say, 1/2 x squared, but it can be any number between 0 and 1. Half is between 0 and 1. So the idea behind this is that y gets turned to half y. So all the y values get cut in half in this particular case. So let's do that. So we have I'm going to draw our toolkit function again. So our toolkit function, 0, 0, 1, 1, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and again, normally we would do, one, right one, left 2, 4. But in this case, what we're going to do is we would go right 1, but instead of going up 1, we're going to go up 1/2. And then we're going to go over 2. Instead of going up 4, we're going to go half that amount, so we're only going to go up 2. Okay, so we have our vertex, up 1, right 1 over 1/2. So I'm right at y equals 1/2 there. And I'm going to go over 2 and 2. I can also do 3 and 4.5, because 9 is divided by 2 is 4.5. 3, 1, 2, 3, 4.5. And then you get symmetric points over here as well. Normally it's also 4 and 16. So we can go 4 and 8. And so we get a graph that looks something like this. All right. And so when you get a compression, generally, by kind of squishing it down, you make it kind of wider, generally. Okay. So that's our vertical stretching, vertical compression. So now we have 3 things, right? So we have, or 4 things. We have 3 or 4. Shifting, reflection, and stretching and compressing. So I don't know if you want to count that as 3 or 4, but that's what we have. So what you can do is you can take all of those things and put them together into one equation. And that equation is this: y equals ax minus h squared plus k. All right. And so if you've studied quadratic equations before, you might have seen the other form, which is ax squared plus bx plus c. But this is a slightly different form. So you might be familiar with, or more familiar with, having seen this. If you took algebra with me, this is kind of the form that we used, because we didn't know about graphical transformations. So now that you know graphical transformations, you can kind of do it like this. So this A right here, it actually tells us 2 things. It tells us about vertical reflections. Basically, there's a vertical reflection if it's negative. If it's positive, then there's no vertical reflection. It also tells about vertical stretching or compression, which is if it's greater than 1, then it's going to be a vertical stretch. If it's between 0 and 1, then it's going to be some sort of compression. This value of h tells us the shift, either to the right or left. And this k tells us a shift, either up or down. All right. So you really have all the information you have in this form. These are just like 2 different forms of the same thing. If you were to do FOIL on this, you could put it into this form. It turns out that this value of a is the same as this value of a. So even though these forms look different, these 2 coefficients are going to match up in both forms. So again, one way of kind of thinking about this is just kind of like a transformer. There's like the robot shape, and then there's the car shape. Actually, maybe this is more like a car, and this is more like a robot. This is the one that's folded up, and this is the one that's unfolded. But, there's like a time and place for this one, and there's a time and place for this one. And they just require different ways of thinking about what different quantities in that equation mean. So what we're going to do is we're going to graph some of these in these forms, and then we're going to graph some of these in these forms, and then see how they're related. Your homework basically is you start off with an equation like this, you graph it using methods we'll talk about here, and then you'll have to rewrite this equation in this form, which once you have the graph, it's a little bit easier, but there are different methods of doing this. All right, so that's basically what your homework is, and we're going to do some examples to kind of show how that works. So let's start off with an example. F of x is equal to negative 2 x minus 3 squared plus 8. Okay, so f of x you can just write as y if you're going to graph this. So let's look at what this thing is telling us. All right, so let's use green for this part, which is this negative 2. So the first thing I see it's negative, and because it's negative, it's telling us that we have a vertical reflection. All right, that negative value tells us we have a vertical reflection. The other thing that is a 2 tells us we have a vertical stretch by 2. Okay. Next, let's look at this minus 3 here. So that's x minus 3, so that's going to be a horizontal shift. And remember that a minus 3 in a horizontal means you're moving in the positive direction, which means you're moving to the right. So this is a shift right by 3. And then I have a positive 8 here. And that is a horizontal shift if that 8 is outside of the function, outside of the x squared. So this is going to be up 8. Okay? So let's see how we would graph something like this. So I know this is going to be in the first quadrant, so I'm going to draw my first quadrant real big. All right? So the first thing I do is, one, is to plot the vertex using shift. All right, so our vertex shift here, I guess I'll use it in blue. Well, here. So the first thing I know is that if I'm moving right 3 and up 8, my vertex is going to be 3, 8. All right, so my vertex goes 3, 8. Yeah, I'll use blue. So I have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay. The next thing we want to figure out is the vertical reflection. So the vertical reflection, it gets reflected, so it should be concave down. And then we have a vertical stretch. And the vertical stretch is by 2. So so that's going to affect how we do these relative points from the vertex. Okay. So normally, remember that we would go like over 1, up 1, over 2, up 4. That's our regular thing. But we're going to do, there to be two things that are different. First, we have a vertical reflection, so we're going to be going downward instead of upward. Makes sense. And we have a vertical stretch by 2, so the amount we move up and down is going to be doubled. So in this case, we're going to go right 1, and we're going to go down 2. So you can see we're going down because of the vertical reflection, and twice as far because of the stretch. And then we go right 2, and then we're going to go down 8. So again, we're going down because of the reflection, and we're going to double whatever amount we normally go. So that's how we're going to plot our points. So we go right 1, down 2, and then right 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8. And we should also be symmetric about this line of symmetry, right? There's a line, vertical line that goes through the vertex, and we should be symmetric about that line. So our graph should look something like this. So this is our graph, y equals negative 2, x minus 3 squared plus 8. Okay, so in a lot of cases, people really like this form because it's actually usually, it's usually pretty easy to graph it if you know how to interpret the meaning of these numbers. So if you understand the pattern and interpret the numbers, then you can kind of plot the vertex, figure out the vertical reflection, vertical stretching, and then figure out how you're going to move your points relative to that vertex. You can usually graph these pretty quickly. So I'll do another example, and then I'm going to give you one to try out on your own. So on the homework, I also have given you some graph paper, so you won't need any graph paper when you do this homework. But let's do f of x is equal to 2x minus 3 squared plus 1. I'm just going to rewrite this as y. In a lot of cases, as kind of like a rule of thumb, you can think of f of x as basically being y. I think that is not a harmful way of thinking about this. So I don't remember the color convention I used before. So first thing, we look at this. It's positive, so there's no vertical reflection. So there's no vertical reflection. But there is a vertical stretch by 2. So I use 2 a lot, but it could really be any number. It could be 3, 17, 120, whatever the number happens to be. All right, then I look at this. Negative 3 tells me I'm moving 3 to the right. And then this number outside tells me the vertical shift. And so this would be 1 upward. All right, so let's graph this one. All right, I also know this is going to be in the y-axis. So I'm going to draw the vertex. So the vertex should be 3, 1. Yeah. So I'm going to draw that vertex 1, 2, 3, 1. And then I have normally my graph would be again 1, 1, 2, 4. That's for my toolbox. But in this case, I'm going to have a vertical stretch. So my vertical stretch is going to make that y go up more. So I go 1, and then instead of 1, I'm going to go up 2. And I go 2, and instead of 4, I'm going to go up 8. All right. I'm going upward because there's no vertical reflection. So let's do that. So I go 1 over 2 up, and I go 2 over 8 up. 1, 2, 3, 4, 5, 6, 7, 8. And again, I have this line of symmetry. So then it should be on the other side of this. It should be a mirror image. Okay, and that would be my graph y equals 2 x minus 3 squared plus 1. Okay? All right, so I'm going to give you one to try out on your own. So the one I want you to try is this one. F of x is equal to negative x minus 1 squared plus 4. All right, so the first thing you need to do is figure out if there's a vertical reflection, then figure out if it's vertically stretching or compressing, and then figure out if it's being shifted to the right or left or up and down. I'll give you a 3 count. You can pause it and try to do it yourself. Otherwise, after I count of 3, I'm going to do it myself. All right, so let us do this one. So y equals negative x minus 1 squared plus 4. So again, the first thing we're going to do is look at this right here. So what that tells me, it's basically a -1. So that is telling me that we're going to have a vertical reflection. So there is a vertical reflection, but there's no vertical stretch. So no stretching in this case. Then I'm going to look at this -1. And the -1 tells me we're going to move 1 to the right. And then we're going to look at this it's 4. That tells us we're moving 4 upward. So having that information, I already know that the vertex is going to be 1, 4. All right, so that's what I'm going to do. So let's graph this. So I have my vertex is 1, 1, 2, 3, 4. And normally, again, for a toolkit, we go 1 to get the relative points to the vertex, and then 2, 4. But since we have a vertical reflection, we're going to do something different. So instead of going up, we're going to go down, but there's no stretch, so we still go by the same amount. So we're going to start 1 over, 1 down, 2 over, 4 down. We could do 3 and then 8 again, but it's all right. We'll just stop there. And then we have this line of symmetry that goes, there's vertical line of symmetry that goes through the vertex. So we can plot the other points just by doing a mirror image. And we can kind of connect them. And the graph you get should be this. So y equals -x minus 1 squared plus 4 is the graph that you should get. Okay? All right. All right, so the next thing I'm going to do is I'm going to give you some, we're going to do some that are similar to what you're asked for to do on your homework. So what I'm going to give you in the homework is I'm going to give you something in the form of, I'm going to give you something in this form, and I'm going to ask you to do 2 things. The first thing is to graph it using this form, and the second thing is then rewrite in the form ax minus h squared plus k. So basically you graph this, and then you have to rewrite it in this form, ax minus h squared plus k. And I'm going to go through some examples of how you would do something like that. All right, so let's start off with our first equation, y equals -x squared plus 4x plus 1. All right, so the steps to graph something like this, if you took algebra with me previously, we did this extensively, but even if you haven't, we'll kind of go through it. So the first step is the concavity. So basically, if A is positive, this first thing is positive, then it's going to be concave up. If A is negative, then it's going to be concave down. So in this case, it's going to be concave down here. So why don't I use, I'll use red to represent the answer in this case. So A is equal to -1. So this is going to be concave down. The next step is to do the y-intercepts. So the y-intercept value is going to be equal to c, which is this quantity right here. So actually, let's write this. So A is equal to -1. B is equal to 4. And C is equal to 1. So our y-intercept in this case is going to be equal to 1. Number 3 is to find the vertex. So there's a vertex equation, which is x equals -b over 2a. So what you do is you plug in b and a into this to figure out the x quantity of the vertex, and then you take that number and you plug it back into this equation to find the y. So you put those together and you get some quantity, you get some coordinate for the vertex x, y. So if we do that in our case, x is equal to negative 4 over 2 times negative 1, which is negative 4 over negative 2, which is just positive 2. And then what we do is we take that and we plug it back into the original. So we have negative 2 squared plus 4 times 2 plus 1. So this is negative 4 plus 8 plus 1. So that means y is equal to 5. So we put those together. X coordinate was 2. The y coordinate was 5. So that's my vertex. And then the last step is to find the x-intercepts. And what you do for the x-intercepts is you basically set the equation equal to 0. So you set y equal to 0. So 0 equals ax squared plus bx plus c. And to solve this, what you should use is the quadratic equation. So x equals negative b plus or minus the square root b squared minus 4ac over 2a. All right. And then that would give you your x-intercept values. So again, this is kind of like, there's some interesting patterns in here that I'd like to point out. One of them is that this vertex equation for x is actually built into this quadratic equation. It has to do with the symmetry property of this thing, but negative b over 2a is actually, if you divide that first term in the numerator by the denominator, that's actually that vertex is actually that value. And then this tells you how much you go to the left or right of that line of symmetry, which is kind of cool, I think. So in this case, I'm going to have to do it on the side here. But we'll use the quadratic equation. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So x is equal to negative 4 plus or minus the square root of b squared, which is 4 squared minus 4 times negative 1 times 1 over 2 times negative 1. So what we get is we get negative 4 plus or minus 16 plus 4. Here, I'll just show that step. So we have a double negative, which makes this a plus 4. So this is minus 4 plus or minus the square root of 20 divided by negative 2. So you could literally just calculate this. Square root of 20 is also equal to 2 square root of 5. I don't know. I guess I should show that. So 20 is 4 times 5. And if you have a perfect square inside of your square root, you can take it out front by taking the square root of it. So it's negative 4 plus or minus 2 square root of 5 over negative 2. Divide each term in the numerator by negative 2. So this becomes negative 4 over negative 2 is positive 2. And then it doesn't really matter, but if you see a plus or minus multiplied by negative 1, sometimes people flip it and write it minus plus. And this becomes square root of 5. So those two x-intercepts are 2 plus square root of 5 and 2 minus square root of 5, right? So if I can calculate those. Two solutions. So 2 plus square root of 5. We get 4.23. And then also the other solution would be 2 minus the square root of 5. It's negative 0.23. All right, so those are my x-intercepts. All right, so those are the steps that you would do. I'll just mention this. You can also solve these using completing the square. Basically, it's this equation. You can do that with completing the square if you know how to do that. Sometimes you can also factor these. In this case, we had these, so this would be a hard one to factor. Usually, you can try factoring it, but that's also another alternative method. So we have all this information. Let's actually try to graph this thing. So let's write all the information that we know about this. So the first piece of information is we know that it's concave down. We know the y-intercept is equal to 1. We know that its vertex, we've calculated, is 2, 5. And we also know its x-intercepts are equal to 4.23 and negative 0.23. All right. So with those pieces of information, that's basically all we need to actually graph this thing. So let's graph it. All right, so let's do the vertex first. So it's 2, 5. 2, 1, 2, 3, 4, 5. So that's my vertex. My y-intercept is 1. So there's my y-intercept. And then I have my x-intercepts. 1 is at 4.23. So I'm going to go 4, 1, 2, 3, 4. And I'm going to go like 0.23 is like a quarter of the way. So something like that. And then I have negative 0.23. So I'm going to go negative a quarter. You know, just try to make it close. That's where it crosses the x-axis. And then we can kind of connect the dots here. Ugh. Okay, so my line got kind of ugly there, but hopefully you get the idea. All right, so that's how you would graph it. The next thing that you would do is try to get into the form. So this HK is basically the vertex, right? So it's 2, 5 will tell you kind of its vertex values. And then this A value, there are a couple ways you could get this. The first way is that it should match the A in the original equation. So whatever that leading coefficient is, so in this case, our leading coefficient was A equals negative 1. So this A should also be equal to negative 1. All right. So you can put those together is negative x minus 2 squared plus 5 would be that equation in that form. I'll just tell you an alternate way of you could think about it in terms of the relative position is you know that normally we go 1, 1, 2, 4. This is for the original y equals x squared toolkit. But in this equation, let's look at how we move on the vertex. So let's move. We have a point over here. Or we could look at this point, right? Well, these points are too good. But we have an integer point right here. So we can see from that point, we've moved 2 this way. And then we've moved 1, 2, 3, 4 downward. And you can see that basically that's very similar to this one, 2, 4, except we're going downward. We're also going to the left, but symmetric in each case, just because we have this point happens, our other integer point happens to be there. And you can see that basically that corresponds to a vertical reflection with no vertical stretch, which is consistent with it just being A equals just negative 1 only. Okay, so you can see that if you have some integer points, you can kind of figure that out. I'll show you a little bit later a more complicated version of this where you don't have integer points, but this is basically what your homework is going to be like. You have 2 long ones, kind of like that. So I'm going to give you one to try on your own. So I'm going to give you y is equal to negative x squared minus 2x plus 1. And again, what you're going to do is you're going to find the, you're going to graph it, find the concavity. What are all the steps? Find the concavity, find the y-intercept, find the vertex, and then find the x-intercepts, and then graph it, and then put it into the form ax minus h squared plus k. Right, I'll give you another 3 count to pause it, to try it on your own, and then I am going to go through it. All right, so let's do it. So the first thing I like to do is I like to identify, I'm going to do this in blue, A, B, and C. So here A is -1, B is -2, and C equal to 1. So the first thing this tells me, I see a negative sign for A, so that tells me we're going to be concave down. The y-intercept is the value for C, so the y-intercept is going to be 1. My vertex, first I figure out the x value is -b over 2a, so that's negative of -2 over 2 times -1. So this is 2 over -2, which is -1. And then I'm going to plug that back into the equation. -1 squared minus 2 times -1 plus 1. So what happens is if the negative sign is outside the parentheses, it doesn't get squared. -1 gets squared, so that negative remains. -1 squared is +1. -2 times -1, that's a double negative. That makes it +2. And so our vertex value is -1, 2. And then we're going to figure out our x-intercepts by setting y equal to 0 and applying the quadratic equation or completing the square. So if 0 equals -x squared minus 2x plus 1. So you could plug it into the quadratic equation. Negative b plus or minus the square root of b squared minus 4 times a times c over 2a Okay, so we get x is equal to 2 plus or minus the square root of positive 4. -2 squared is positive. And then this is plus 4 over -2. So this is 2 plus or minus square root of 8 over -2. Square root of 8 can be written as 4 times 2, and the 4 can be pulled out. So this is 2 square root of 2. And when you do this, you get -1 minus plus square root of 2. And you can calculate those x-intercepts by plugging in. So I'm going to get -1, whoops, let me turn it on, -1 minus square root of 2, -2.41. And then I'm going to do -1 plus the square root of 2, and 0.41. You can also do this by completing the square. I don't know. If you don't understand completing the square, in my opinion, is a lot of cases like the algebra is much simpler, but you have to know more about the steps to do it. So let's graph this thing. So I'm going to put my vertex as -1, 2. And then I'm going to do my y-intercept, which is 1. I kind of went off the line there a little bit. And then my x-intercepts are -2.41. 1, 2, and a little bit less than halfway. And then 0.41. Whoops, what did I do? Oh, I'm sorry, I drew the vertex in the wrong location. All right, so yeah, I was like, this thing doesn't look like it's supposed to. So you go, it's -1, 2, so you go left 1, up 2. There's my vertex. And then my other point is 0.41, which would be somewhere like halfway, a little bit less than halfway to between 0 and 1. So then I have my points. I can kind of graph them. It'll be something like this. Okay, so that's my vertex right there. All right. All right, so then again, you have to put it into the form y equals a x minus h squared plus k. And when we look at this, obviously A is going to match up, so A was -1, so this should be y equals -1. You could put it in parentheses if you want. X, and then it's going to be the vertex. So it's -1. X of minus -1 becomes +1. And then we go up to, that's +2, so this is your equation. Okay? There's another thing also, remember, if you can see here, you go, it's between this point and this point. It's 1 to the right, 1 down, which would tell you that there's no vertical stretch, which is consistent with it being 1, but you're going downward, so that's why it's negative. So again, if you can figure out points that are integers, you can kind of figure that out. All right, so this is basically what your homework is like. Figure out these things, given this equation, figure out these things, and then once you have those, you should be able to rewrite it into this other form. You may be curious also, I probably should have showed this on the other one, like, are these two equations actually equal? And you can show that they're equal if you just sort of work them out. So if we do the FOIL thing, so we have -1. If you do FOIL this, it is x squared plus 2x plus 2. I've done this enough that that one's fits a pattern that I know. So you put negatives on all these, -x squared, -2x, -2 plus 2. Wait, did I screw this up? Because I noticed that this 2 canceled out. I'm trying to figure out, did I screw something up here? So x squared, oh, I'm sorry. Yeah, I did screw this up. This is +1 here, okay? Sorry about that. So then this gives me -x squared minus 2x plus 1, which is exactly the same as this form. So these two are equivalent, but they're just share kind of a pattern. Two different ways of showing the same thing. All right, so you should have enough to do your homework. I just want to show you a kind of more complicated version, or kind of a complication that you may see. You're not going to see it on this homework, but you may see it somewhere else. And I just want you to have seen it somewhere. So we have this function, a is equal to 2, b is equal to -6, c is equal to 7. All right, so I'm going to go through this kind of quickly, but it's kind of the same. Concave up, or y-intercept, is 7. Vertex, I'm going to skip the work for the vertex just to kind of save you some, well, yeah, so the vertex is kind of a weird one. So in this case, it's 1.5 and 2.5. So you could plug in these numbers. The vertex doesn't have to be integer values. So it's possible that it could be something like this. But what I want to show you are the x-intercepts. So again, you start off by setting y equals 0 and solving for x. And if you do the quadratic equation on this, negative b, which makes it negative of -6 is +6, square root of b squared, which is -6 squared is +36, minus 4,